All right. So who am I? I've been an SRE at Google for about 13 years. Before that, I was at various Google engineering teams, and I've kind of got done the grand tour of SRE at Google. I started over in ads. I was in privacy for some time, and currently I'm in infrastructure. So compute engine over in Cloudland, and most recently infrastructure as a service, which includes compute engine, GKE, and storage and friends. And please don't ask me about storage. I just know how to point to, so I can find you a person if that's what you're interested in. AIOps, are we there yet? And the title of this talk is brought to you by my toddler and also by my general personal impatience with like the future not just being quite as good and awesome and as here yet as I'd like it to be. So here we are. Should we all go home? Are we all done? Do we solve all our problems? And we'll, put some ML and some cardinality, and we're all good. So a really important, I think, SRE value, right? Like Google SRE value, but really a general SRE value, maybe a general software engineering value, right? Is that automating stuff is cool, and like I'm lazy, and these things are really hard, and I just mostly want things to be solved, and I want to go to the beach and have a nice day and have beautiful sunny days instead of worrying about how to shepherd like complex computer systems. This ML thing comes along, it's pretty neat. Can I just throw it at some systems, and see what comes out? And just be done and go grab some coffee or some beers and go hang out. Sadly, the answer is no, at least not yet, right? This hasn't happened, as far as I know, at a really large scale or solve really large scale infrastructure problems. But what has happened, it has happened, to me, and I'm sure to many of you, is this huge new pile of work called MLOps and making sure the ML models are healthy. The future leaves a lot to be desired, right? And there's like buffering for movies, like and all these things. But anyway, all right. So just a quick primer and taking a little bit of a step back, right, with the terminology here. And I'll admit I don't love the names, but these feel like they are the industry norm names. And if folks have better ideas for names, I will, take it and maybe we can run with them and convince people to change them. Maybe it's still early enough. Okay, so. SRE for ML or MLOps, right? So this is the humans making the models happy. And I kind of tend to think about this a little bit as like model zookeepers, right? The models are not quite yet cattle if we go back to the kind of infrastructure things that we talk about. And it's, there's lots of engineers building these really complex models very fast, right? So sometimes not with the greatest reliability characteristics we'd love for them to have. And how do we keep them running, and how do we keep, all the new cool features in good shape? And this is pretty classic SRE things, right? It is distributed system design, and there's maybe even larger systems than we're used to. It's hardware deployment. And this particular piece of hardware with accelerators is really expensive. There's not a lot of it, right? And it has really interesting new characteristics. It draws a lot more power than perhaps compute did before. And how do we make sure these things are like really, really efficiently scheduled? Someone made a joke at work that these things are so expensive that you could actually just assign like a human butler to each one of them and it'd be totally fine. But hopefully not for long, right? The trust and safety piece, super important here, right? Like how do we make sure like these things are aligning with our standards and the results are what we expect them to be, particularly in a non-deterministic environment, like how do you test these things, right? And lastly, like very traditional sort of operation and automation, right? Like how do we deploy these things, roll them back when we invariably mess up, right? How do we do maintenance? How do we make sure we have, how do we deploy with great velocity, et cetera? So nothing super new here, other than it's harder and faster, and people are very excited about it. And then there is AI for SRE, or AIOps, which is really the thing that I just want to happen and solve my problems, right? And it is the computer solving my problem as opposed to me shepherding the computers. Some examples are, can Gen AI write some postmortems for us or some great documentation? Because, my to-do list to make that my documentation for my team, like, it's really large and I haven't gotten to it and I'm probably not going to get to it, but maybe someone will, maybe the computers will. General workflow automation, right? How can we get things to work together in a way that's a little bit simpler and scales a little better? Observability and risk evaluation. I'm super interested in this. Can we get better insights from just really complicated systems and understand, outages, or maybe even like, can we figure out an outage about to happen to us before it has actually happened, because that would really help with the mean time to recovery. And lastly, like resource efficiency, and this is becoming more and more important, right? Like how do we make sure that all this compute and other resources we're deploying gets used really efficiently? So why do I personally care about this stuff, right? So before ML, there was infrastructure, and that's what I've been working on for a really long time, right? And there are a lot of really hard problems in distributed infrastructure that are really not very amenable to human scale tracking, or even sort of human scale automation. And it'd be really nice if there was some techniques that would make my life a little easier, right? And can solve them, and I can go play some beach volleyball instead of like spending all my time like shepherding like really complex computer systems. And I'll touch on this a bit more, but I really believe that reliability is by no means like a solved problem for these large distributed systems, right? And we don't necessarily have a way to really fully understand what is happening at all times. And I find this super interesting, right? And I think this is going to get harder because the scale is only kind of increasing and accelerating. And then yeah, ML came along and made it all even harder. But at least we now have pictures. And the only reason we have pictures in this talk is because of ML, because I have no artistic bones in my body. So you're all welcome. And, ML ops is very much a really big part of the hard problems I've had to solve recently. And I'm sure, we have to, as a group, have to solve. And it breaks all sorts of rules in really annoying ways. And all these like sort of simplifying assumptions we made over time. So simple example is, how do you distribute resources, right? Like how much storage do I need for a certain amount of compute? How much power do I need? How much cooling? How much network capacity between clusters, right? And this is all different. And I'm sure there will be more of these that we haven't thought about yet. And they will be hugely painful because, turns out web services have certain characteristics that we've gotten very used to. And we don't even remember the assumptions we make for things to kind of work. On top of this stuff, like this stuff is really cool, right? So the kind of the user expectations and the user journeys are actually super different, right? Really simple example, while I was making the stock, right? Like it took seconds for these images to pop out, and sometimes they weren't even the ones I wanted, so I did it a few more times. And yeah, I was willing to wait seconds for the results, right? Like in this sort of search world or ad world, that'd be kind of unthinkable, right? Like people would sit there and wait for like 10 seconds for their search result. Like your company wouldn't be there for very long. And that's changing and getting better, but it's a kind of an interesting when you think about it, right? Like, oh, like if I have to design for inference, maybe I can have outages there seconds at a time, right? Because nobody is that sad about it. All right. Okay, but kind of back to my previously existing hard problems, right? And sort of the non-ML operations, which still have a lot of challenges and are still very unsolved. I have this distributed system, right? Like I'll talk mostly about compute because that's the thing I have the most depth in. And I'll use those examples. And I have to figure out, is it working, right? Is it behaving the way I want it to behave? And we have this, we have SLOs and error budgets, and those things are great. And it's really good to have some sort of metric that's like, hey, like, we can negotiate velocity and we can negotiate alignment with our dev partners. But SLOs like quickly start to break when you need to get into more complex systems, right? So they're really great. But as you get into more scopes, so if you have hundreds of scopes or maybe thousands of scopes, kind of going back to the cardinality talk, right? Or if you depend on your user behavior for your outcomes, then you very quickly kind of get into trouble. So my example here, this is an internal dashboard we have for our SLOs for our compute engine. And these are just, and it's on purpose very hard to see because that's the point. And you also don't care. But on the upper axis is the actual cloud zones. And it's actually much longer to the right, but I couldn't get my browser to stop crashing. So that's what we got. And then on the y-axis is the actual APIs we have and the associated SLOs. So there's sort of latency and uptime and things like that. And, what am I supposed to do when it becomes not green? This is not actually a screenshot of a bad day because I'm clever. So, there's still some not green in there, which you might infer as, not great. So do I page someone every time a square goes not green? Like my team is very quickly going to get very unhappy with me, right? And is it even bad, right? Like, so how do I even know? How do I set this? There's this kind of this idea of SLOs, like, oh, like you set it at the level that makes, your happy SLOs, right? You set up whatever numbers that makes your customers happy. If you guys have seen this happen, please let me know. I mostly set it at whatever number sort of works and doesn't page me too much, right? But then it gets trickier, right? Let's pick our simplest API. I have to list my VMs, right? And my user must know what VMs and where they are and what they're getting billed for and all of that. So that seems easy. Okay, imagine I have a user that has one VM, right? And I have also a different user that has millions of VMs across continents. And I have to set up a good latency threshold for when both those customers are happy with their outcomes, assuming they're reasonable, right? Like there's always the like, well, it should be just instantaneous and magical. Like, what is wrong with you? But so, to set a target for latency for that one VM, right? That I noticed if that got a little worse, it's going to be really hard, right? If I set the same target for the one that lists a million VMs across continents. So now I have to pick a number that is like, not very good for noticing if the one VM got a little worse, but also kind of makes me not get paged all the time. And you might say like, okay, cool, I can have different targets, right? Like, why don't you have buckets, which seems like a totally reasonable idea. But then how many buckets do you have, right? Like, and how do you distribute those buckets? And now this like horrible graph becomes a hypercube. And what do you do with that hypercube in actual real life? Like, I'm a huge believer in dashboards that are things you like. They trigger actions, right? If your dashboard makes you sad and that is the only thing your dashboard does, like it's not that useful unless it's making managers sad, and then that's okay. But that's a different talk. So that's the easy example, right? But now I have the hard example. Like I have, my user is running something they presumably care about in, a VM, or maybe they're running, a query into BigQuery to understand something about their data. And how long should it run, right? Is it working in some way that is nice? Did it get worse? So how do I even start to know that if the user changes their code, or maybe I changed my code, or the kernel has a bug, or the kernel got faster? This gets really hard really quickly, and SLOs don't quite do the job here. So the good news is that we found that with some like pretty like simple, sort of clever mathematical techniques, like things got a lot better, and we got to sort of detect a lot of interesting stuff. So I'm going to talk about that for a second. And now you will notice that these are like pretty simple statistical models. They're not quite ML, but like it kind of gives me a lot of hope that these simple things made life like quite a bit better. Do we learn? And my slide, okay, it has animation. I forgot about the animation. Sorry, I'm just going to do the whole thing. Okay, that most systems actually have a pretty stable core or sort of recurring workloads, right? So the user that listed a VM yesterday probably lists a VM today, and like tomorrow, and the user that listed a million VMs does the same thing. The folks running their website kind of is the same website most every day. And that performance is workload contingent, right? Unsurprisingly, listing one VM faster than listing a million VMs, and that we can derive some information from this. And the first thing we learned is that variance is bad. Variance means something sad happened in your system, or something happy, right? Like you can have a failure success, but something that you will have to address as a human, at least for now, has happened to your system. And the customers really care about variance, right? If like it took you 2 seconds to list your million VMs, and now it takes like 15, like you're annoyed at me. But if it takes 2 seconds again, like that's just how life is. Maybe it's bad, but like you don't know the difference. And generally, unexpected variance is a sign of something bad has happened. And sometimes it's a sign that your user changed something, right? Like you can be like, well, their website got really popular, and now instead of having 100 7-day actives, they have 10 million 7-day actives, and things got different. We probably still need to do something though, right? And it'd be cool if we had a general version of this, and so that's what we built next. And it's this cool generalization that can be done. You kind of grab the historical service data, 3 logs, you partition that into cohorts. So like the different users doing, maybe I have a million users that are listing one VM, and I have maybe 2 users that are listing millions of VMs, right? Compute like their baselines of outcomes. And this just assumes like whatever is happening today is good, which may not be true, but is as good as it gets, right? Like you pick a good day to do this, or you don't do this when you're having an outage. And then you measure this, and then you measure sort of the variance from that median. And this actually gives you a ton of insight and a ton of really good information, and lets you debug your systems. And yes, this is not actually ML yet, but I do feel like this is kind of a signal towards that direction, and kind of tells you a little bit of what kind of like system insights you can derive with this kind of thing. So some actual unique things. So my talk is not a total trick, and there's some actual ML stuff. So this one is actually a little bit older, but I think it's really cool because data center efficiency is a fun topic, but there's really significant improvements with applying an ML model to data center cooling, right? So this graph shows just the actual power utilization ratios here, and lower is better, as you might gather from my talk topic, and with ML on and off. So this is the ratio of the data center power utilization from total power divided by IT power, right? So IT power is the stuff you actually want to use. It's running the computers. The other power is sort of cooling and bathrooms and everything else. So lowering this ratio, in this case, it was a 40% lowering, which is a pretty neat result, right? Like it's very hard. Usually these things are kind of measured in 1 to 2%. Then of course, code assists and things that can help us, scale, automation, and write code faster. And I find that all I mostly started writing code when I was C, and recently I started writing some Python, and I'm like, everything's so easy now. But then it gets harder. I don't know. And there's some other neat stuff. I call out to folks from Run One and Kyle, who'll be talking later today at 12:30. And there's I think there's so much coming up in this space, right? So like, why should you care? And that's basically why, right? Like, I think these problems are not getting any easier, right? They're not getting any simpler. They're not getting any more amenable to sort of, just trying to stare at graphs and making sure that the graphs align in certain ways. And, particularly infrastructure problems, gotten tougher. And like the techniques we have are not like, they're not, you can't just scale those techniques, right? The desire, and then the desire to understand what's working, when it's breaking, trying to predict outages, trying to predict doom, is getting bigger and bigger, right? The scale of deployed computation is accelerating, which to me is kind of phenomenal, right? Like given the size we've gotten to, and these problems have gotten harder and harder and more existential, right? So people are they depend more on this stuff, right? I was flying to London a few years ago, and all the computer systems weren't working, right? Like I just at the airport, and you don't actually need the computer system to fly planes, but it turns out you do need them to like print boarding passes, right? And they actually did all the boarding passes by hand, which I know was kind of amazing. Took forever, right? And I think the AIOps and this whole space is likely to be a super interesting set of tools, right? And I think SRE has a real opportunity to shape where this goes and how can it be helpful. And I believe folks in this room are probably going to be dealing with much of that going forward. So I'm really happy, looking forward to chatting with everybody. Quick acknowledgement to the folks that did much of the actual work I presented here today. If you want to get deeper into this stuff, there's some good books from Google SRE. There's many other good books also. And if you have any questions or thoughts, I'm really looking forward to the rest of SREday. And if there's anything now, or I'll be around. Really appreciate the time.
Thank you, Thais. Any questions?
Hey, for the statistical workload characterization stuff, do you think that would work at companies smaller than Google? So almost everyone is not at Google scale, yes. Right? So the question is, like, for companies that are like orders of magnitude smaller, do you think those approaches would work?
I think it would likely work. So, just intuitively, like without validating this, we did also try it in smaller services and saw some pretty good results. Now, if your workloads are all completely random somehow, right, like it won't work. So there's some are your users generally using the thing in a somewhat similar way every day? Like one thing that makes me very nervous, and I mentioned this briefly, right, is like this whole idea of I think we've forgotten how many assumptions we've made for sort of normal web services, right, that run on things, and that the new services are going to be really different, and we're going to find all those sharp corners, right? And we're starting to find them, but I think that there will be more of them. But I do think it should work, right? Like, but you probably need like sort of 1,000 things that more or less happen the same every day, right? But because even some of the services we did try this on actually have a very small end count of large users, so it should.
Yeah, on the same topic of characterizing groups of traffic workloads that might be self-similar, do you recommend that we should cluster the different workloads based on similarity in that one metric, or in other variables that we might know about those workloads, and try and like characterize customers by their size instead of by their latency characteristics?
So I think you can, we kind of tried a bunch of things, to be totally honest and transparent. And one thing that was really, really interesting that we found is that we just did clustering of a bunch of things together. And it kind of, the clustering was a little surprising, right? So basically like it's a complicated way of saying like, if you even an expert human in those systems, if they were trying to just look at the graphs and kind of try to derive the same results, it wouldn't have worked. So it can't be like a single metric isn't as interesting as kind of a cluster of metrics, right? So the most interesting stuff came when like, we kind of let the high cardinality grouping happen, right? Which a human couldn't do. Like, it's like, oh, if this four things fluctuate together, right, then you have some signal of something bad is about to happen. But actually, if only one of them changes, like it was, it wasn't a good signal. So there was some interesting stuff there.
Apologies. Any other questions?
So the techniques that you are using, did you open source any of these? Or
So I don't think there's any open source actual code. The code itself is very uninteresting and very sort of Google specific in the sense that we're like reading Google logs from Google services. But there are we've done publications of this, and there's a recent, like literally I was working with someone like on the talk they were giving at one other SRE conference in Europe this week. So there are talks that are very specific to this and go a little bit deeper that are not public. In fact, I think there's some at the Usenix SRE Con. So happy to find those references if folks are interested.
Hi, for the agentic workflows you mentioned, do you have any examples of like anything that is deployed at scale?
Sorry, can you repeat the question?
For the agentic workflows you mentioned, any examples of what kind of workflows have you leveraged AI for?
So I don't have any good examples, but maybe Kyle has some good examples.
Okay.
I feel like a lot of this is pretty experimental, and I will freely admit that, being a person that's been in infrastructure for a long time, like we're pretty conservative people, right? So I did, some people, when I was telling them I was giving this talk, they're like, you're like the curmudgeon-y person that wants everybody to code and see like what is happening. But I think there are examples, and there's examples that are pretty cool, actually more externally to Google than internally.
Okay, thank you.
Do you want to add anything, Kyle? Okay. All right. Any last question before we take a break?
Hi, I'm way back here. I don't know if you can see me. Sorry, I'll step over here.
All right, thank you.
Hi, thanks for the talk, super great. I think what I'm really interested in is what do you think are the most promising techniques that we haven't really shaken out all the wrinkles yet? Like where do you think the next 18 months are going to go in terms of techniques for this? Thanks.
I mean, predicting the future is terrifying, but I think the observability piece to me seems like the most interesting, right? Because it's also a little less scary, right? As you start to talk about, a lot of the ML stuff, right? Where it's like, there's a little bit of randomness, right? There is a little bit of, I don't necessarily really want like ML deploying things to my systems just yet, but observability is less scary, right? Because you're like, hey, like maybe if you can get me some good insights and point me the right direction, then that's super helpful, right? And maybe and I think maybe that, right? Like sort of talking about like showing people the right dashboards when they get started, right? Kind of clustering the right information. Some of the stuff we've tried has been, hey, there's a bunch of outages, are they related? And trying to tell me that. That's super useful. I'm not aware of this work, but I think on the cloud space, right, for an end user of cloud, like one of the biggest, hardest things, like, hey, is my stuff broken, or is my cloud provider stuff broken, right? And being able to tell that very quickly, I think that it will be in the kind of next 18 months is something I'd love to see, right? And that I think will be really actually improve things quite a bit, right, from where we're at today.